Today's content is about inefficient index seeks. Now, I know many of you will have variety of experiences with SQL Server. You might be working as a developer, DBA, and your relationship with indexes could be like basic, intermediate, advanced. And things about indexes is such a thing that despite working with SQL Server for so long, I keep coming across so many different caveats about indexes. We keep learning as we do a lot of trial and error, with indexes, specifically with multi-column indexes. When you're dealing with large data, how the optimizer really thinks and how it behaves, and the choice the optimizer makes when it has to choose a specific index to access the data. So the content that I'm presenting today with the basic demonstrations here is again based on a recent consulting engagement where I was sitting across with some SQL Server folks and we were trying to troubleshoot a few things. And then this discussion came up about indexes, the order of columns, the selectivity thing, the hints that SQL Server is giving, the missing index hints, etc. So I thought, why not design a session around that and present it to the community? And today is today's webinar content is the result of that discussion. So to some of you, this content would seem like very basic, maybe like basic to intermediate. Some of you might be like, this is really how it works. And despite working for a long time with SQL Server, you would be like, okay, I didn't know about this. So yeah, let's be honest with each other and see if you think, oh, this was very basic. Let me know if this was very basic and trivial. But if you think that, yes, you have learned something new today, do let me know, because that also gives me a lot of feedback as to, okay, this is the kind of content that I can probably present quite frequently. I mean, the idea is I don't want to make assumptions as to what the community knows and doesn't know. Okay. So before we begin and jump into the demos right away, you know that most webinar content is straight away jumping into the demo without any PPT and without any talk, too much of lecture. We straight away jump into the demo. Let's answer some housekeeping questions that you may have. First one, about the webinar recordings. All the webinars are recorded. They are available on sqlmaestros.com. That's the website you should go. And you can really figure out things yourself on the top level menu. There are links to video courses, masterclass recordings, webinars, etc. I want to let you know that some webinars are freely available. Some are priced very nominally. This just helps us to run the show. So you can take a free membership on sqlmaestros.com that will give you access to all our free content and you're not paying a single penny. If you think that, okay, you could pay some money to SQL Maestros, so you will get a premium membership where you will have access to all the paid webinars and all the advanced demos and tutorials. So we have two video lobbies, the free video lobby and the premium video lobby. And if you really want to dive deep into SQL Server performance tuning from start to finish, then the best thing that is available today on sqlmaestros.com is the 40 hours deep dive masterclass recordings. This is a live batch that was delivered, and the entire 40 hours content, 10 sessions of 4 hours each, makes up about 40 hours. Those HD recordings are now available for lifetime subscription. Yes, this is important that you subscribe once and you are a lifetime member, which means you can watch the content as many times over the next few years, anytime, anywhere, of course, all demand access. Okay, that was everything all available on sqlmaestros.com. And if you want all of this content for your team, like a group of 3, 4, 5, 6, 10 people, then just drop an email to contact@sqlmaestros.com. All right, friends. So let's get started with inefficient index seeks. Now, in AdventureWorks, there is this table called sales order header. Let's look at the data once. So let's go and execute. I'm sure if you have been playing around with SQL Server, you know AdventureWorks database and you know this table as well. There are a couple of attributes here in this table, and this is a typical orders table. So you have the sales order ID on the left side here as the first attribute, and we can really assume this is the clustered index. This is the primary key and the clustered key as well. Let's move towards right, and there is another attribute here called territory ID. If you scroll down and look at territory ID and the values, the distribution, you will see a lot of single digit numbers there, 1, 4, 8, 9, 10, 3, 7, etc. Just trying to show you that territory ID or territory ID, I mean, the way we pronounce it, okay, has looks like it ranges from 1 to 10. But sales order ID has to be unique because this is the primary key. Each ID here represents a specific record. Okay, that's about sales order header table. Now let's do something. We'll turn on statistics, time, and IO. And now we are going to run a simple select statement. Select star from sales order header. Let's go and execute this. Now, this is the most simplest T-SQL query you could ever write, which is select star from the table, which is get all the data, all the columns, all the data from this table, no predicate at all. Let's jump over to the execution plan. If you look into the execution plan, again, no brainer. It's a clustered index scan. This is what you expected because there is a clustered index on the table. All you're telling SQL Server Optimizer is, I just want to fetch all the data. So there's really no brain that Optimizer has to apply here. All it has to go and fetch all the data pages and render the data to the client. If you jump over to the messages tab, we have turned on set statistics IO. So we can look at some IO metrics and you will see the number of pages that were read. So we can see about 689 pages that were read to serve this query. All good. Now we'll modify the query a bit. We'll say select star from sales order header where sales order ID is greater than 1, right? I understand it's a bit of a dummy query. You would like, why greater than 1? You could just put a real sales order ID number. I can, but then still the result will be what I'm trying to show you here. So let's just put this up. And you can see the note. Okay, you will have access to this script from the SQL Maestro's resources section. So observe the seek, and I'm trying to say this is an inefficient seek. And as we move forward with the demo, I will prove my point. So let's go and execute this. Now, what happens with queries like this? Jump over to the execution plan. You will see that now there is a clustered index seek operation that SQL Server is choosing. The optimizer chooses an index seek. So this is in contrast with what you got earlier. Earlier, you got a clustered index scan because there was no predicate. Just go to the storage engine, fetch all the data. But now you have a predicate. The predicate is on sales order ID. And because the clustered index is on sales order ID, SQL Server decides to do a clustered index seek operation. Now, I call this as an inefficient seek. Why? If you jump over to the messages tab, okay, before I jump over to the messages tab, what do you think a seek operation really is? In the chat window, quickly, maybe just one liner if you could type. What do you think a seek operation is? Scan, we all know, we just go and fetch all the data pages because you're reading all the, the data. What do you think is a seek operation? Be it a clustered index seek or a non-clustered index seek, simply what is an index seek operation? Okay, some answers are coming in. So someone talked about a table scan is same as clustered index. Yeah, of course, table scan and clustered index scan is same. So a table scan happens when a table does not have clustered index. Okay, looking for particular data. It was about the filter data. We're looking for points directly to the data where it is, seeking data from leaf pages of the index. Table scan fetch only the particular data. Okay, some of you are trying to express what index seek operation is, but technically the answer that we all expect is with the, where is the zoom toolbar here? Okay, there you go. With the index seek operation, the optimizer is traversing the B tree structure of the index. So, the index is the B tree structure. So you have the root page, you have the intermediate level, and you have the leaf level. If you're relatively very new to indexes, there are a few webinars and a lot of videos on sqlmaestros.com that talk about the index architecture. Do go watch those videos and those sessions and content. So we are talking about traversing from root to intermediate to leaf level. Why? Because you want to directly go to the data that you want to seek. Seeking, you're finding the data that you really need. You don't want everything. The idea here is to get to the data faster. So we create indexes so that we can get to the data faster. That is all. Getting faster to the data improves or results in that improved query performance. Now, The seek is happening here, but if you jump over to the messages tab and let's scroll down, you will see that logical reads are again 689, which means again you are reading all the pages. Now, if you're again reading all the pages, which means again you're reading all the data, then this kind of seek is inefficient. So just take a note. Just because you're seeing a seek operation doesn't mean that the query is perfect and the index is perfect and it's giving you the best performance. No, not really. Behind the scenes, something else is going on. There are two things that we're trying to look into, which is how many pages were read and how many rows were read. If you look at the result set here, the table has 31,465 rows. If you look at the status bar there, that's the number. So if we are reading all the pages, I can make that assumption that the operator clustered index seek actually read these many rows. So let's jump over to the execution plan. Take the cursor over the arrow here, and you can see two important metrics here: number of rows read and actual number of rows returned. So the number of rows read were 31465. Now, this gets us thinking as to seeking is supposed to extract specific records based on the predicate that we are trying to read, based on the predicate. So we want selective data, and which means we should be touching selective pages and selective rows, seeking, traversing. We are bypassing all the unfiltered stuff, the filtered stuff. So this should be really less. But then you can clearly see that number of rows read and the number of rows returned clearly tells us that we were actually trying to read all the data. So where is the problem? We wanted to read all the data because we said sales order ID is greater than 1, which means we want all the data. So we have to read all the data. Which means when you are doing a clustered index seek, try to find out a gap between number of rows read and the number of rows returned, or actual number of rows returned, whatever the terminology there is. Right now, there doesn't seem to be a gap. Whatever you read was being returned. So here it looks good. But then you get the point that a seek has to be efficient if it reads selective data. Now let's bring up the scenario. Let's blow this up. In a typical multi-tenant environment, this is a common thing. You just can't write workloads and queries like this, where you are putting up a predicate, you are trying to seek selective data, but you land up reading all the data from the table. Doesn't make sense at all. So you got to introduce a tenant here, like a warehouse ID, a salesperson ID, a territory ID or something, and make the query more selective so that you only read selective data and that selective data is being returned. So at this moment, just try to understand what seeking operation is, what you're trying to do. With seek, you only want to fetch selective data. And if you want selective data, you have to make the predicate more selective. Okay. Just keep following the content and we will come to the conclusion very shortly. So what we try to do here is, let's make the predicate more selective and add a tenant. For example, we can put up something like territory ID is equal to 1. Now, what we're trying to do is make the entire thing more selective. We say where sales order ID is greater than 1. This is similar to what we had earlier. Now we introduce another aspect to the predicate and we are trying to make the data more selective so that we only get what we want. Let's say, this kind of report is based on territory IDs. Okay. Anyway, this is just a tutorial. So with whatever query, whatever business sense the query makes, let's go and do this. Now, if you execute this, when you execute this query, optimizer will choose the best index that is made available to it. Okay, so we have a clustered index. We might have a couple of non-clustered indexes on this table. Whatever is made available to the optimizer, it will choose the best index in most cases. Now, let's jump over to the execution plan. What you can see that SQL Server Optimizer has again resorted to clustered index seek. Why? Simply because it thinks that Doing a clustered index seek is the fastest operation. It is the most efficient thing to do. Why? Because you're wanting all the attributes. So you have put a star there. You want all the attributes and you have put sales order ID greater than 1. Now, even though you're trying to make the data selective, still clustered index seek is the best choice. But is this index seek efficient? Now, if you look at the result set, you will see 4594 rows were returned. So this time, we have less data. This is about 14 to 15% of the overall data that is being returned. Remember, we have 31,000 rows approximately. So we have less data being returned. But if you check the number of rows read versus what is returned, now here you will see a difference, or the differences will start popping up. Now, if you see here, 31,000 rows read, and we have actual number of rows returned 4594. 31,000 rows read, which means I'm sure if you go over to the messages tab, you will see again all the pages were read. Okay, friends. We are coming closer to understanding what inefficient index seek here means. This is a good example where you have a seek operation happening, but you're still going and reading all the data, even though you don't need all the data. But there is a small catch here. The catch is we don't have the right non-clustered index right now on the table to support this query. So this conclusion that I'm trying to show you, which is inefficient seek, now I'm going to transpose this into a non-clustered index seek, and the message will get more clearer. If you look into the Management Studio execution plan here, you will see that SQL Server is trying to hint you that probably a non-clustered index will make a lot of sense. Now, why? Because you have put territory ID as another predicate. This hint wasn't coming earlier, but now because you have territory ID also as part of the predicate, it's trying to tell you that you can probably have good performance impact if you had a non-clustered index in place. You know what? We will look into this recommendation in a while. So what I'm going to do is just right click and click on missing index details, but not show that to you right now. Let's just park it in another window. We'll come back to that later. We want to first investigate and do a lot of trial and error ourselves. Now, we have some choices here. Let's create the right indexes. We have two options. Option one is to create an index with sales order ID and territory ID. That is option one. And option two is territory ID, comma, sales order ID. Two options. Why are we, friends, there could be multiple options as well. You could just take a single column index and try to put one of the attributes in the included keyword. You can do all of that. But I'm just trying to cut short and not just over elaborate the concept, just trying to keep it very simple. We have two predicates here in our query, sales order ID and territory ID, and we are filtering on both of them, and we want to seek on both of these attributes. So what I'm trying to do here is just simply create a multi-column index based on these two attributes. So these two columns, these two attributes will become our index keys. And the only confusion, the only choice that I'm going to present to you right now is sales order ID, comma, territory ID. That could be option one. And the other option simply could be just reverse the keys, reverse the columns. Now, option one, option two. We are going to try both the options and we'll understand why we have chosen a specific option. And then we will go and look into the recommendation also by SQL Server, why SQL Server is recommending a specific option. Now, what do you think? Should we go with option one or should we go with option two? Just don't randomly give me an answer. Just think and try to give me your rationale also in the chat window. Why should you go with option one? You can just type option one or just type one. And if you want to really put up a note as to why you think you should go with option one or option two. Okay. Few suggestions are coming. Option one to two. Couple of you are recommending option two. Okay. Very few option one. Someone said option two, more selectivity. Okay. Okay. If sales order ID is more selected, then it should be the first column in the key. Very good point out there. Okay. Option 2, equal search. Good point out there. Okay. Let's jump back to them. Thank you. Thank you everyone for all the responses. Now let's talk a bit about selectivity because some of you brought that up and that makes a lot of sense. The attribute itself is not selective. It is the query that makes the query selective. So what I'm trying to do is let's just go down very quickly because that should be demystified a bit. So I am going to probably just show you the selectivity part. This one. Let's check the selectivity. We have two attributes here, territory ID and sales order ID. There's a lot of confusion about what do you think selectivity really means. If I look at the distinct values there in territory ID, let's go and execute this. There are only 10 values. Remember, I told you in the beginning, maybe the territory IDs are from 1 to 10. Only 10 distinct values. But if you look at sales order ID, the unique values that are there are 31,465. So by simply looking at the data, which one do you think is more selective? Let's not get into any further discussions about if and buts and yes and no. By just simply looking at the distribution of data in these two columns, which one do you think could go more selective? Okay, some people are talking about territory ID being more selective. Some are talking about sales order ID. Well, friends, if you just look at the data without really understanding the query, without really looking at the query, we could say sales order ID is more selective or could be more selective simply because it has most unique data. It has more unique data. But does the data itself decide selectivity? The answer is no. And this is what I want to demystify. It is the query. It is the query that decides selectivity, not the data itself. What is selectivity really is? It's the number of rows matching the predicate divided by total number of rows. This is a very simple formula deciding the selectivity. High selectivity means low number of records are being returned, and low selectivity means high number of records are being returned. So in simple words, it's all about the predicate. If you look at sales order ID, which is 31465, if I write a predicate like give me data from this table where sales order ID is greater than 1, then sales order ID has the most unique data. This is supposed to be more selective. But if the query says greater than 1, which means give me all the data, which means the query is low selective, it's going to return high number of records. So if you take this example, select start from sales order header where sales order ID is greater than 1, what do you really get? All the data, which is very, very low selectivity. In contrast, if we say where territory ID is equal to 5, let's go and execute this, you are getting just 486 rows. So we could say this is being more selective. So it really depends on the predicate. It depends on the predicate, this overall thing, and your relational operator, which is part of the predicate. And you know that range operators make a lot of difference with the optimizer, choices of index, the filter, the predicate, etc. And of course, it will be one of the deciding factors also in the choice of index columns. So in other words, if I simply put something like this, let's take this one, right? And if I just, this one produced 31,000 rows, but if I just copy this here and say, if I put this, what happens next? Now, the same table, the same data becomes highly selective. Just one row. It's the same attribute, but what happened? Predicate changed. So it's the predicate, it's your query that decides selectivity. Likewise, territory ID equals to 5 gave me 400 odd rows. And if you just simply make it greater than 1, again, you are going to get a lot of rows. This is not being selective enough. Right, friends? So that's about selectivity. Okay, let's go back. Now, This being said, friends, there is a general rule. There is a general rule which is like in a multi-column index, when you are choosing on these index keys, column 1, column 2, put the most selective column as the first attribute in a multi-column index. Put the first, the most selective column as the first column. Now, I have some issues with that recommendation. The most selective column goes as the first column in a multi-column index. Fair enough. But I also need to know that how is that column being used in the query? Is that attribute being used with equality operator or with non-equality operators? That makes a lot of difference. Again, boiling down to the fact that you have to look at the workload and the queries as to how selective the query is, highly selective or low selective. Now, let's proceed with the demo, and everything that we talked about just now, selectivity, etc., is going to get demystified. So we have two options, option 1 and option 2. We are going to play around with both of these options. Let's first test option 1, where we put sales order ID as the first attribute. Why did I take this as the first attribute? Simply because in a forum and with this customer, when I was talking about, everyone talked about this idea and this best practice, which is put the most selective column as the first attribute. And many came up with this idea of putting sales order ID as the first attribute because looking at the data itself, it's more unique. So it's more selective, that kind of assumption. So let's create this index now. Let's do this. And let's test option 1. We have the same query now. Okay. Let's see if this index gets used. So we are going to execute this now. And we get the data. Let's jump over to the execution plan, and you will see that the index is not being used. SQL Server still decides to use the clustered index seek. Why? Despite this non-clustered index being there, it probably finds that is going to be an inefficient option. Seeking on the clustered index is still a better option. Now, what we do here is look at the amount of rows that were returned. So we have 4594 rows returned, about 14 to 15% of the data. We'll change the predicate a bit. We say territory ID is equal to 5. I know that this is going to return less number of rows, but I only want to see, is the optimizer thinking something differently when the number of rows reduced? If you want to watch the remainder part of the webinar, and all the remaining demos, you can subscribe to the webinar on sqlmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to sqlmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestros membership. So the first link on SQL Maestros says join. If you click on that, it will bring you to SQL Maestros membership. Things are very simple. There are two membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos, and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on SQLmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So in summary, you can go to SQLmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on SQLmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL.